Hello everyone, welcome back. In the last video, we demonstrated that if the price were to be anywhere different from 0.633, we have an arbitrage strategy that we can form. So if the price of C is greater than 0.633, we can always use portfolio A to arbitrage. If price of C is less than 0.633, we can always use portfolio B or strategy B to arbitrage. And the only difference is that if the price is deviating by a different amount, the arbitrage profit will be different. But you can always scale that up by any factor, so that difference doesn't create an issue for us. So now, based on no arbitrage, we know that the price of C must be 0.633. So okay, we have more confidence now of the price must be 0.633. However, it still doesn't quite answer the question why the actual probability of the stock price becoming 22 versus dropping to 18, that probability doesn't really matter here in the actual calculation of C. So it still seems a little puzzled that although we know this price is probably the right number, the right price, because it cannot be a different price. The market cannot sustain a different price. But it's very strange that why this price is not relevant to the actual probability of something materialized in the real world. So in this video, we'll try to answer that question. Now, suppose that somebody just is really good and they will analyze the market, and suppose the person knows the real truth that for sure there's 80% chance that the stock will go up to 22. There's only 20% chance that the stock will to go down to to $18. Maybe this person is from the has 4 dimensions or something. So you looked at all the possibilities of ever happen in the world and really are able to determine that this is the true probability distribution. Okay, so okay, then in that case, the person will say, okay, fine, given I know this, then the person think, since I have this quote unquote true information here about the distribution, maybe I can do something about it. So say the person is willing to pay 70 cents for C, a little higher than what we have calculated. Now look at this person. Will the person be making money? Well, if the price becomes 22 in 3 months, the person will earn $1, right? For each C he owns. So if the actual probability is 80%, he expects he is expected to get 80 cents, and you discount that, that value is 77 cents or 78 cents. So it's actually above the price he paid. Okay, so on average, he's expected to make some money. He's expected to make about 7, a bit more than 8 cents on average. So it's expected to make that. So after knowing the truth, he thinks that he has some advantage. But are we saying this person also arbitraging the market? given the truth, or quote unquote truth that he knows, what the actual distribution of the market is? Because on average, it's actually making money. Well, yes and no, because in a strict definition, he's actually not arbitraging the market, because if we look at the definition of arbitrage, you have to take absolutely no risk, and you make money by taking absolutely no risk. Okay, and not just that, you have to make money without any of your own investment and taking no risk. Here, he can, if he can do lend and borrow, and he probably doesn't have to use his own money, but he is actually taking risk, because it's only on average making about 8 cents. He's not making that in every scenario. Okay, so there are certain scenarios that it's gonna lose money. So strictly speaking, he's not arbitraging. So, but if there exists somebody like that, and the person thinks that it's taking advantage, knowing what we know, without knowing the truth of what the actual distribution of the stock price, we can actually do better than this person. So, so why that is the case? The key piece of information here that allows us to take advantage is this risk-free interest rate being 12% annually, because this is really the key to resolve this puzzle here. The person offering 70 cents for C will be compensated on average for about 8 cents for the risk it's taking, okay? However, if you look at what is being implied by the 12% interest rate, the market actually is willing to compensate you for about more than 14 cents for the same amount of risk, because there exists an interest rate of 12%, risk-free interest rate of 12% annually. Okay, so this asset in the market is only worth 0.63 cents, although the expected value is 80 cents discounted at 12%. So you actually better compensated by the market. The person has chosen a particular compensation scheme where he's willing to be, he thinks being compensated for about 8 cents is good enough, but market actually rewarded more. So we can actually then, based on the arbitrage strategy that we talked about in the last video, we can actually take advantage of this person by trading with them. So in this case, the value is greater than 0.63. So we're gonna use a strategy A and trade with this person to take advantage. So the key thing here is this risk-free interest rate. The risk, if you really think about it, in the market, that there are actually two aspects that are important. One is the probability in the real world something happened. What's the real probability of going up versus the probability of going down? But that's not the only factor. There's another factor that's very important, which is how much compensation, what is the risk, what's the risk premium? How much is the market willing to compensate you? So it's really the combined effect of the probability distribution and the risk premium that determines the price, not any of either of the factor alone. So if you just focus on the probability and without considering the risk premium, you actually are not getting the full picture, and you're not getting the right price. So you have to take both information into consideration, both the probability of something happening, and also, for that particular probability distribution, there's a risk entailed, and how much market is willing to compensate for that risk. And that information is embedded in the at the risk-free rate of interest. So that's why when we did our calculation in the very beginning to reach that value, we didn't need to know what the actual probability of something happening, because by knowing the risk-free interest rate, we know both the well, not them separately, but combined, what is the combined effect of probability of something happening and the risk premium. So if the actual probability of going up is 80%, then you look at it, the risk neutral probability is 65%. Because in the risk neutral probability is where I do an expectation and I call this the price. Okay, so I'll get 65 cents in 3 months and discount it back, I'll get 63 cents. So the risk-free, risk-neutral probability is 65% versus a real-world probability of 80%. And the difference is actually what the market will compensate you for the risk you're taking. Okay, in the next video, we're gonna talk about how we actually calculate this risk-neutral probability through the same example. Okay, I'll see you in the next video.